Okay, let us now take a look at question number 3 in formative exercise 1.4. Okay. Let's go through the question and try to understand what the question is asking. The diagram on the right shows the cross-sectional area of a tree trunk. You can see here a tree trunk that is floating, partially floating on the surface of the water. Tree trunk with radius 46 cm. So take a look at the diagram. So this radius is given as 46 cm, floating on the water. 3 points, the points P and Q lie on the surface of the water. So you are shown here points P and Q, they lie on the surface of the water, while the highest point R is 10 cm above the surface of the water. Now you can see the tree trunk is partially visible on top. Okay, so this part is visible, this part is above the water, the rest of the tree trunk is under the water, it's not visible. Okay, so you can see a small portion here, and then you are told that despite the highest point here will be 10 cm measured from the surface of the water, above the surface of the water. You're asked to find what is the value of theta in radians. What is this angle? Okay, so if you try to plan how to solve this problem, you'll notice that radius is given 46 cm. This radius is also same as radius from O to R. So if you draw a vertical line, this will also be equal to 46 cm. Okay, but the distance from R to the surface of the water here is 10 cm. So it means we can find what is the distance from this point to O. Okay, so if we know the distance from this point to O, and then if you know that radius 46 given here, then you can use these two values and cosine formula to find half of angle theta. So that is how we are going to solve part A. Okay, so as usual, the first thing we do, draw a diagram first. Okay, draw a diagram first to show the surface of the tree trunk. Okay, it's a circular section. That will be the tree trunk. So label the center. The center is point O. Okay, draw a horizontal. So I'm going to use the line here as a guide. So this will be the surface of the water. So I'm just drawing a line from O to this point over here. Okay, and then another line from this point. Okay, so this is assumed to be the surface of the water. Okay, water surface. And then this will be labeled as P and Q. The highest point will be R. Okay. And then what we do here, okay, you also given this angle, and this angle is theta. Now draw a vertical line, another dotted line, a vertical line like this, so that the vertical line will cut PQ at point S. So we label this point as S. Okay. So we are going to find angle theta using this triangle. So you'll notice that here, because the surface of the water represented by PQ and OR are perpendicular to each other, then this angle must be 90 degrees. Okay. So I'm going to draw this triangle. I'm going to draw this triangle outside so you can clearly see what is how to find the angle theta. You're also given this is 46 cm, so we write here 46 cm. Okay, so this is a right angle triangle. So if you draw a triangle like this, okay, so this angle is 90 degree. This is 46 cm. This is O. This is Q. This is S. Okay. So we are asked to find what is this angle. So this angle now will be theta divided by 2. Because the vertical line, vertical line is a bisector of this angle. So either side the angle will be equal. That will be equal to pi over 2. So what about this side here, OS? Do we know this side here, OS? So OS will be equal to OR minus RS. So what is RS? RS is given to you. This is 10 cm. And this part here is given to you is 10 cm. So that is the part visible above the surface of the water here. So this is RS. So in part A, cosine of theta over 2. Okay, cosine of theta over 2, if you remember from right angle triangle. So cosine of this angle will be given by, so this part here on the left hand side of the triangle, you have 46 minus 10 cm. So this will be 36 cm. Okay, so that is the length of this side here. So we know the length here, we know this length. We can find the angle using the cosine formula. So this will be 46 minus 10 divided by 46. Okay, so we are showing the detailed working here, working in your solution. So this will be 36 over 46. Therefore, theta over 2, if you use your calculator, you will get cos inverse of 36 over 46. Okay, and theta will be equal to 2 times 2 times cos inverse of 46, 36 over 46. So if you use your calculator straight away, you'll get the value as 77 degree. Okay, but the answer, you are asked to find the answer in radian. Okay, so we convert this to radian. So this will be equal to 77 degree times 3.142 over 180 degree. Okay, you'll get the answer theta as 1.344 radian. Okay, so that will be the answer for first part. Then what is the angle? Now in the second part, in part B, you are asked to find what is the arc length PRQ. PRQ. So you remember the formula for arc length. We are using S equal to R theta. R is known, theta we just calculated. So it's very simple to find the arc length. So in part B, arc length PRQ is equal to R theta, which is equal to 46 multiplied by 1.34, which will be 61.827 cm. Okay, so that will be the arc length. Now in part C, you are asked to find what is the cross-sectional area that is above the water. Okay, in other words, you are asked to find what is this area above the water. In other words, you're asked to find what is the area of this segment. So the area of the segment here, if you can shade this part, you're asked to find in part C what is the area of this segment. Okay, so it's very easy to find area of segment because it's given by area of the sector multiplied by the area of the triangle. Okay, so we have done this many times. So we just apply the equation directly. Part C, cross-sectional area above water equal area of sector OPQ minus area of triangle OPQ. Okay, area of sector is half r square theta, so this will be half time r will be 46 times theta. Theta is 1 0.344 radian. And we already calculated this earlier. And then area of triangle will be half AB sine C, half A, sorry, A will be 46, AB times sine of 77 degree. And now the sine will be in degrees. And so if you work it out, you'll get 1421.952 minus 1030.883. So you'll get 391.069 cm square. Okay, so that is the cross-sectional area above the water. Okay, let's go through very quickly one more time. So you are shown a part of a tree trunk, okay, submerged below water, partly visible. Okay, we know what is the radius, and then you are told the visible portion. Okay, the visible portion above the radius is also given. Okay, from here we can find what is the value of theta, and then we can, first part you asked to find what is the angle theta, so we use half of this triangle, and then we are using arc length. Second part we are asked to find what is the arc length, the PRQ, arc length given by r theta, and finally the last part, cross-sectional area above the water. Okay, we'll stop the recording here.